Imagine this, just 40 light-years from where you're sitting right now exists a solar system that has astronomers worldwide holding their breath in anticipation. The TRAPPIST-1 system, discovered in 2017, contains not one, not two, but 7 Earth-sized exoplanets orbiting a small, cool star. 7 potential second Earths in such close proximity? It seems almost too incredible to be true. This discovery represents one of astronomy's most exciting finds in decades, and NASA has turned its most powerful tools toward this cosmic neighborhood, including the revolutionary James Webb Space Telescope. What NASA has discovered about these worlds takes our understanding of potentially habitable planets into an entirely new dimension. The implications for finding extraterrestrial life? Absolutely mind-blowing. Welcome back to your channel name, where today we're diving deep into the TRAPPIST-1 system, quite possibly humanity's best hope yet for finding life beyond our solar system. If you're fascinated by space, exoplanets, or the search for alien life, you're going to want to stay until the end of this video. Let's put this discovery in perspective. At just 40 light-years away, TRAPPIST-1 is practically in our cosmic backyard. If our entire Milky Way galaxy were the size of the United States, TRAPPIST-1 would be just a few houses down your street. That's astonishingly close in astronomical terms. What makes this system so special isn't just its proximity, it's the unprecedented number of Earth-sized planets packed into such a small area. All 7 planets orbit closer to their star than Mercury orbits our Sun, yet because TRAPPIST-1 is a small, cool red dwarf star, at least 3 of these planets sit comfortably in what astronomers call the habitable zone. The habitable zone, or Goldilocks zone as it's sometimes called, is the region around a star where temperatures could allow for liquid water to exist on a planet's surface, not too hot, not too cold, but just right. And as we all know, where there's liquid water on Earth, there's almost always life. But before we get too excited about booking your interstellar vacation, let's take a deeper look at what NASA has discovered by pointing its most advanced instruments at this fascinating system. When NASA first discovered the TRAPPIST-1 system, scientists could only guess at the true nature of these planets. But then came the James Webb Space Telescope, humanity's most ambitious and powerful space observatory ever built. With its massive 6.5-meter primary mirror and suite of specialized instruments designed to study infrared light, James Webb has given us unprecedented insights into these distant worlds. The initial spectral analyses from James Webb have been nothing short of revolutionary. For the first time, astronomers have been able to detect potential atmospheres around some of these planets, atmospheres that differ greatly from Earth's. One planet might have a particularly dense atmosphere similar to Venus. Another could be a water world with global oceans. Yet another might harbor volcanic activity that's reshaping its surface even as we speak. The tidal forces from TRAPPIST-1, the gravitational pull between the star and its closely orbiting planets, could be creating unique climate patterns we've never seen before. These forces might be heating the planets from within, potentially creating conditions favorable for life even on worlds that might otherwise be too cold. Most fascinating of all? A striking number of these planets show signs of having intact, though perhaps thin, atmospheric protective shells. Without such protection, radiation from their star would likely strip away any chance for life to develop. Now, let's take a tour of each of these fascinating worlds, exploring what James Webb has revealed about their unique characteristics and potential for harboring life. TRAPPIST-1b was the first exoplanet in this system to be classified as Earth-like in terms of size and composition. Orbiting closest to the red dwarf star, this planet receives significantly more radiation than Earth does from our Sun, despite the star being much cooler. For years, scientists assumed TRAPPIST-1b had been stripped of any atmosphere due to its proximity to the star. The intense stellar radiation would, theoretically, blow away any gas envelope surrounding the planet. But the James Webb Space Telescope has revealed something astonishing: TRAPPIST-1b likely has a thin atmosphere after all. How is this possible? The answer might lie deep beneath the planet's surface. The JWST's mid-infrared instrument, MIRI, has detected peculiarities in the thermal emission from TRAPPIST-1b that suggest active geological processes. In other words, this planet might be alive with volcanic activity. Imagine standing on TRAPPIST-1b's surface, the sky would appear a deep red due to the star's color. The ground beneath your feet might periodically tremble as magma shifts beneath the crust. In the distance, volcanoes could be erupting, spewing gases that replenish the thin atmosphere that would otherwise be stripped away by stellar radiation. By isolating individual wavelengths of light reflected from the planet, James Webb has created spectral analyses that identify specific gases present. The initial results confirm a rocky surface composition, but also hint at gases that could be produced by intense volcanic activity. What's missing from the data? Any significant traces of water. Without water, the chances of finding life as we know it on TRAPPIST-1b seem slim. But the volcanic activity presents an intriguing possibility. If these processes are ongoing, they might be creating conditions that could support more exotic forms of life than what we're familiar with on Earth. Scientists are now working to pinpoint the exact transit times of TRAPPIST-1b across its star to gather even more precise observations. With each transit, James Webb can gather more light from the planet, building a clearer picture of this fascinating volcanic world. Moving outward from the star, we encounter TRAPPIST-1c, a planet that has presented researchers with a cosmic mystery. Early observations suggested it might have an extremely dense atmosphere, similar to Venus in our own solar system. Kindly like, share and subscribe our channel for further more updates about space.